Hey, ChemStars, this is Mrs. Vanderlei bringing you the answers to the objective check for the BCA Mass to Mass. I really hope you are staying on a schedule and so you're not waiting till the last minute to do all this work. You should have been doing this on Tuesday and then move on to the next topic on Wednesday. So hopefully you are staying current. Well, how do we go about doing this? Again, what is always our first step? The first step is always to, you got it, balance it. So let's go ahead and balance it. I would save copper and silver for last. Why? Because they're elements. So let's do nitrogens and oxygens first, all right? So here is nitrogen. I got one of those. Oh, look at that. I got two nitrogen on this side. So I need to put a 2 here. Now what? I have 6 oxygens. I have 6 oxygens. So let's go back and check our elements. I have copper 1. I have 1 copper. Oh, look at this. I have 2 silvers, and now I need 2 silvers. Okay, so what's the second step? I need to fill out the BCA table. So let's read the problem. It says how many grams, periodic table, of silver are produced when 34.69 grams, periodic table, of copper are used with excess silver nitrate. So what goes in here? I just said moles goes in the BCA table, doesn't it? I'm not given moles. I'm given grams, periodic table. So I need to find out how many moles of copper is 34.69. So that's what this little spot over here is how many moles of copper is 34.69 grams. Hey, what goes on the bottom? Grams, periodic table. So I use this number. And then what number goes on top? 1 mole. And I end up getting 0.5459 moles, all right? So now let's fill out the BCA table. Okay, the first thing is the B, the before. How much stuff do we start with? Well, remember, it has to be in moles. And we just calculated right here how many moles of copper we have. Now, what does it say here? We have, what's that? Excess silver nitrate. So I'm going to put excess here. And if you recall, how do we always fill in the B for the products? We start with 0. We don't have any to start with, all right? Does that make sense? Before you start, you have nothing that you've made, right? So you don't have any products yet. So now what? I need to subtract out all my copper. I am assuming all of my copper is now used up. So how do I go about and filling in the rest of the C? All right, hopefully this is getting a little bit easier for you. Now, how do I do it? I take what I have, divide it by the first coefficient times the second coefficient. So what is 0.5459 divided by 1 times 2? And I got 1.092. All right, let me show you another way. I think this is how Ms. McCauley does it. So she does it by factor labeling. Well, how many moles right here, I'm looking for this number again, of silver nitrate do I have with 0.5459 moles of copper? Now, what unit must go on the bottom? 1 mole of copper. What unit must go on top? Well, it needs to be moles of silver nitrate, and that's where this 2 comes in. So I have 2 moles of silver nitrate, and guess what I get? 1.092. All right. So how I do it and how Miss McCauley does it, how does that work? Well, notice that we divide by the 1. I said divide by what you have, so divide by 1 because 1's in the denominator, and multiply by what you want, which is the 2. So divide by 1 times 2. Look over down here now. So I took this, divide it by 1 times 2, and there's this. And what is the purpose for this? Notice that this is still a 1-to-2 ratio. All right, this is a 1-to-2 ratio. This is double this number, just like this is doubled here than the copper is. Okay, so I could do the exact same thing again for the silver nitrate. All right, I'm sorry, for the silver, and I get the same number. You notice that? These 2 are the same numbers. How do I know that? Because look, these 2 are the same number. I'm keeping that same proportion. So without doing much math, what number can go here? Well, this is a 1, as is this. All right, so it's the same number as the copper. And so one other thing you have to keep in mind, notice that my signs, I'm subtracting always my reactants. I am adding always my products. Why is that? Well, because you are using up your reactants, you are losing your reactants, and you are gaining, you are making more of your products, okay? So let's fill in these last numbers here. All right, so we have a 0, right? Because I've used up all my copper. All my copper is gone. So what about this next one? What is lots and lots and lots of silver nitrate minus 1.092 is still lots and lots, all right? I don't know how much. And then 0 plus 1.92 and 0 plus, and there you go, okay? So I filled out my BCA table, but have I answered the question? Well, what's my question? I've already forgotten. All right, here it is. How many grams of silver have you produced? All right. Well, folks, 1.092 is not grams. What is that unit here? It's moles, isn't it? So now I need to convert how many grams are in 1.092 moles. Well, what unit has to go on the bottom, everyone? That's right, 1 mole. What goes on top? 1.07 or 107.8. Where'd that come from? The periodic table. And so what do? I multiply. So this is my answer. That's how many grams of silver that I'm going to create. That's a lot of silver. You can get pretty rich off of that. All right. Then you have a bonus. All right, now I crossed out the word molecules and put atoms. Molecules would be if I want to know how many molecules of silver nitrate or copper nitrate if you have a compound. But I would use atoms because silver is as an element there, all right, and then show all work. Well, folks, I just factor labeled again. I took how many moles of silver I had, 1.092 times, you recognize this number, I hope, and I got 6.572 times 10 to the third atoms. So I hope this helped. As always, if you have any questions, let your teacher know. We'll see you next time. Don't wait to be great. Bye-bye.